Batteries are a very fascinating and wonderful invention, to put it mildly. But there are certain batteries which are very useful and very special. That is the 18650 lithium ion battery or cell. The 18650 cell is extremely useful in that you got more voltage on it than you have from a AA. AA, rechargeable AA is 1.2 volts. Lithium ion, 3.7 volts. You can easily get a lot of current out of these little batteries. As a matter of fact, they're very dangerous. Never short them out. They can cause fire and explode. They're very dangerous cells to deal with. So they must be treated with respect. They must be charged with respect. Constant current, constant voltage type charging. Never exceed 4.2 volts. Don't put too much current into them. Never short them out. Don't let them get too hot. But these batteries can be expensive new. There are some cheap knockoffs you can get on eBay from China. It's from such brands as Ultrafire and stuff like that. But a lot of those batteries you'll find are a lot lighter weight and are cheap ones that instead of a full official slightly heavier cell, you have a tiny cell inside a larger body and very low capacity, definitely a lot lower than advertised. So a good place to find more of these 18650 cells for cheap, but still the good quality kind and not the cheap knockoffs, would be from an old laptop battery pack. You know, a lot of old laptops, they go outdated and people throw them away or they take them to recycling or the batteries go bad. But probably what's really going on in the old laptop cells or the batteries go bad is you might only have one or two cells inside that have actually failed and a bunch of other good cells just wasted. So we're going to crack this open and we're going to access the cells and remove the cells so that we can use them. It'll be rather destructive to the case, but I don't care. We're not trying to restore this original pack. We're accessing an old pack to get at its cells and to remove the cells so the cells can be used in projects and whatever they need to be used for. Okay, so here's the inside. Unfortunately, I damaged some of the insulating material on the outside of this cell over here, but the cell itself should still be functional. All the electrical connections will be removed, of course. You can see right here is a temperature sensor. It looks like there's some thermal paste there as well. It would be used to check the temperature of the cells so that if it got too hot, it could turn it off. It could prevent from overheating the cells. So anyway, but all the electrical connections, we're going to just remove the charging circuit board. We don't really care on that. We want to just remove the cells themselves, or them self, I get it, you know, sell, you know, whatever. Normal. So we removed the circuit board, the charging circuit board here. A lot of small surface mount parts, of course. Unfortunately, some of it's damaged right there with my intrusive entry, but anyway. Got the temperature sensor, and anyway, it would have monitored the cells voltage at several points in order to keep them balanced. But now we can more so take the cells out of the enclosure here. Of course, we're going to have to find where they're all connected so we can disconnect them. Here are the cells removed from the pack. Anyway, it'll be interesting to see if any of them have any usable voltage on them. So we'll do some voltage tests. Here we have a digital meter. So we'll get our first cell here. First cell is reading 2.4 volts, and the voltage we want is 3.7 or thereabouts. So this one's low and will need to be charged. And it is actually a bit low, because I think if you're below 2.9 volts, it's not good. This cell is actually 3.4 volts. This one's definitely has more hope. This one's 2.4 volts. .5 volts. Almost 3.6 volts. Not too shabby there. This cell, 3.4 volts. And finally, last but not least, this cell, 3.5, almost 3.6, 3.57 volts more precisely. So a lot of these cells actually have some hope to them, which is good. I'm going to find the two closest cell voltages. 3.57. It's this one. 3.57. 3.57. These are probably a parallel set. They're going to be balanced already. They'll be a good set. My voice of music recorder, model 760, I had modified it to use lithium-ion batteries. I put a charging circuit inside, constant current, constant voltage, right here. The design is from the website of Battery Gone Wild. And I have it set where it's going to be charging two that are in series. But I don't have any balancing circuit in it. It's just the two batteries and two cells in series. So I want to have the closest I can to a balanced pair. And this should be a nice balanced pair I can put into this Voice of Music reel-to-reel tape recorder. Of course, we want to make sure the polarity is correct here. It may even have enough voltage to run the recorder though I'd like to not run it for long until I've given it a charge. We'll take another voltage measurement to make sure we don't have any shorts going on. 3.569. 3.569. I think we're good here. Pretty balanced. The two are in series, so together I have, it's the other way around, 7.1395 or 7.14 volts. Open circuit, of course. As you can see, there is enough battery juice to run the recorder right now. Although it looks that they are low right now. We'll want to charge them before we put it into official use. Viewers, I want to thank you for watching this video on salvaging lithium-ion 18650 cells out of an old laptop battery pack, and then getting a couple of the balanced cells and putting them into my modified Voice of Music reel-to-reel tape recorder. So here's a schematic for the actual charging part. Now this is not my design. This is by Diode Gone Wild on YouTube. It's got an LM317 ambient transistor. This 4.7 ohm resistor is going to be, the one I used was half watt. Charging current is roughly 200-ish milliamps, slightly above 200 milliamps, you know. Maybe 220 milliamps. Right now it's at 220 milliamps. But it's around there. And then you adjust this trimmer right here to get your maximum charging voltage, which you do not want to exceed 4.2 volts for one cell. So for two cells in series, you do not want to exceed 8.2 volts. Here is a schematic for how I implemented it in the Voice of Music 760 recorder. Obviously, the original Voice of Music wiring was modified. Some might not like the idea of changing the original design of the recorder, but the 12 volt DC input of the recorder, negative is grounded, positive goes through a diode. The 120 volt AC goes to the original transformer, original rectifier diodes, filter capacitor here. They join together. Then here's the charger circuit. Remember, the charger circuit contains a 4.7 ohm resistor between the negative of the battery and the ground. If you connect the negative of the battery to the ground while you're charging, you short out the resistor and you don't have the current limiting function. And then not only that, but also the maximum voltage going to the battery will be a little bit higher than what you set it to. So you do not want to short that resistor out at all. So I have a relay right here with a normally closed contact. Since the recorder has a switch for a charge position or on position, if I put it into on position and you have no charging voltage coming to it and you're just running it on batteries, the relay will be de-energized and your normally closed connections will be connecting the battery ground, or the battery negative, to your actual ground. So you're not running it through the 4.7 ohm resistor, and you'll be able to have a full connection of the battery to the recorder's amplifier and motor, the recorder's circuitry. I have a 1 amp fuse here, so just in case some short happens, the battery doesn't get shorted out and explode or catch fire or anything. Whenever you energize the charging circuit, either by the 120 volt AC through the transformer, filter capacitor, and rectifier, or through the 12 volt DC, you energize this relay so that if you happen to have it in on position, the relay being energized would disconnect the ground connection from potentially being connected to the negative of the battery. So you didn't risk shorting out that resistor. And then the charge position, you connect the charger.